acquisition. And we see that this SCADA is a category of software application that allows industries to control the industrial processes, such as gathering data from remote locations in real time to control the condition equipment. And we see that the SCADA system of hardware and software elements, they help the industrial organization to control industrial processes, and also we see that they help to monitor, collect data in real time. Devices such as pumps, valve, sensors, motors, and more through human machine interface, that is the HMI software. We also see that this SCADA system, they also help to record all the events in a log file. They also help to record all these events, and we see that this SCADA system have got its components, and we see that some of these components of the SCADA system, they include the sensors and actuators. We also see that they include the and we also see that the SCADA system, they include the supervisory machines. Some of the functions of this SCADA, you see that they help in data acquisition, whereby in a real-time SCADA system consists of many sensors and components of gathering to gather information and save the data for further processing. For example, we see that some of the sensors measure the water flow from a reservoir to the water tank, and the sensor measures the pressure the water is being released from the reservoir. So here sensors acquire different types of data to understand all the processes that are going on. Maybe this water is being moved from maybe reservoir A to reservoir B. So there's an information that is being captured at different reservoirs. So you see that this SCADA, they help to ensure that they acquire all the data at every process that is going through. They ensure that all the data has been captured. And you also see that they help in data communication, whereby you see that they uses a wide network to collect and transfer data between users and devices. So at real time, see that the SCADA application, they use components and sensors that are controlled remotely. And we also see that they uses internet communication as well. Since these relays and sensors, you see that they are not able to communicate network between interface and sensors. You see that they also help in data presentation, whereby the normal networks consist of indicators that are visible in order to control. So in real time, see that this SCADA application, there are a lot of alarms and sensors which are not impossible to manage at a time. So you see that the SCADA system, they uses the HMI software to offer all the data that are gathered from various sensors. You also see that they help in monitoring and control, whereby we see that the SCADA system, they uses various switches to operate devices and display the status of the control areas. So you see that at any part can be turned on or off from station using the switches. So the SCADA application, they are implemented to work without any human interface automatically. Only so that only in critical situation will it handle maybe human activities. Okay, let's look also about the industrial Internet of Things. And the industrial Internet of Things, we are going to look about computing in manufacturing, and we are going to look about edge computing. And we see that edge computing, it is a distributed information technology architecture, IT, that's IT, so in which client data is processed at the periphery of network, so as to close the originating sources as possible. So you see that the main goal of this edge computing is that they help to reduce latency requirements while processing data and saving network costs. So let's look about how does this edge computing work. Okay, so we see that in traditional enterprise, computing data is produced at a client endpoint, and so the such as users computer. The data is moved across a WAN, that is the wide area network, such as the internet, through the corporate LAN, that's local area network, where the data is stored and worked upon by the enterprise application. So results of that work are then conveyed back to the client endpoint. Some of the benefits of this edge computing, we see that they help to eliminate latency, and we see that this refers to the time required to transfer data between 2 points in an. They also help to save bandwidth, and you see that this refers to the rate at which data is transferred on a network. You see that it also helps to reduce congestion, and we see that although the internet has evolved over the years, the volume of data that is being produced every day across billions of devices can cause high levels of congestion. So you see that in edge computing, there is a local storage and local servers that can perform essential edge analytics in the event of a network outage. Okay, let's look about computing, cloud computing, and we also see that cloud computing is the delivery of different services through the internet. And you see that these resources include maybe tools and applications like data storage. You see, you have servers, database, networking, and software. So this cloud computing, they works by enabling that clients devices to access data and cloud application over the internet from remotely physical servers, database, and computers. Okay, let's look about the engine blocks. Okay, we see that engine blocks in an internal combustion engine, it is the structure which contains the cylinders and other components, and we see that these engine blocks, they are the backbone of every vehicle, and we see that without the engine block there's no way the vehicle can move. And we see that these engine blocks, they come in different forms, and today we shall majorly be talking about the aluminum engine block and the iron engine block. So we see that an iron engine block is stronger and more durable than an aluminum block. And you see that this iron being stronger, it can withstand the high pressure than aluminum counterpart. When compared to the terms of weight, see that the specific weight of cast aluminum is 2:55 to 2.8 kilogram per decimeter meter cubic, quicker than that of iron. And we see that in terms of strength, we see that the tensile strength of aluminium is between 10,000 to 14,000 psi, while that of iron is between 20,000 to 25,000 psi. So you see that due to strength, massive strength, you see that the iron block can handle more power and boost than the aluminium one because they have less tensile strength. Then you see that in terms of repairing this iron and aluminium engine block, repairing and rebuilding, we see that the extra weight that alumina have can affect the car's performance and fuel economy when it comes to repairing. So you see that it's much harder to repair an iron block than an aluminium one. Then when you see that when components of iron engine block need repairing, it costs you as much as buying a new one, but you just see that somebody will just prefer that let me just buy a new iron engine block instead of just going to repair that iron engine block. So, and you see that it is easier to replace that iron than to just buy it. And when it comes to that of aluminum, you see that it is much cheaper as compared to iron. So in terms of compression ratio, we see that the aluminum one has high compression ratio, which increases the thermal efficiency than the iron, which has got less thermal efficiency. So in terms of thermal expansion, we see that the aluminum have got greater heat expansion than the iron engine blocks, and see that this gives it better heat conductors and also capable of pulling more heat from the combustion chamber as compared to the iron. And in terms of maybe noise and vibration, while the car is moving on the road, there are noises that are produced by the engine. We see that in terms of this noise and vibration, we see that aluminum is capable of absorbing any kind of noise and vibration, while the iron one just that they make a lot of vibration. Okay, let's also look about the petrol engine versus the diesel engine. We see that a petrol engine is a type of internal combustion engine, that's the IC engine, which is usually to powering the light vehicles. And we see that the diesel engine is a type of internal combustion engine, which is used for powering the relatively heavy machines and vehicles. So let's look about how we can differentiate this in terms of maybe definition. We see that in terms of definition, you see that the petrol engine, you see that it uses spark ignition system to ignite the fuel, while the diesel engine, they uses the compression ignition system to ignite the fuel. And then in terms of working cycle, we see that the petrol engine they uses the Otto cycle, while the diesel engine they uses the diesel cycle. And maybe the major parts of the petrol engine, we see that the petrol engine, they have the engine cylinder, they also have the piston, the spark plug, the carburetor, and the intake and exhaust valve. While when it comes to the diesel engine, we see that they have the combustion chamber and cylinder. They also have the fuel injector, the piston, and also they also contain the intake and the exhaust valve. And in terms of maybe air fuel mixing during their time of combustion, we see that the air and fuel are mixed. For a petrol, you see that the air and fuel are mixed in a carburetor before entering into the engine cylinder. But when it comes to a diesel, we see that fuel is ignited by the high temperature of hot and compressed air. We also see that in terms of mean of ignition, the petrol consists of an electric spark plug to produce an electric arc for igniting the fuel, while the diesel engine, you see that the fuel is ignited by the high temperature of hot and compressed air. Then in terms of volarity of fuel, we see that these petrol engines, they have got high fuel volarity. Then when it comes to the diesel engine, we see that they use comparatively fuel of low volarity. Then in terms of fuel consumption, we see that the petrol one consumes more fuel to produce same amount of power, but when it comes to the diesel engine, we see that the fuel consumption is less in case of diesel engine. And also we see that the petrol engine in terms of weight, they are light in weight, while this diesel engine, they are very heavy. And also the initial cost of the petrol is less, while the initial cost of the diesel engine is high. Then you see that in terms of maintenance, when one wants to maintain them, we see that the petrol engine, they are require frequent maintenance all the time, maybe knocking or something, they require you to maintain frequently. And then when it comes to the diesel engine, you see that they require relatively less frequent maintenance as compared to their petrol engines. Then you see that through this maintenance, you see that the cost of petrol is much lower as compared to the cost of maintaining a diesel engine. And we see that this petrol engine, they have the low compression ratio as compared to the diesel engine, which have got the high compression ratio. And now when it comes to starting a petrol engine, we see that it is easy to start a petrol engine due to its low compression ratio as compared to a diesel engine, whereby it has high compression ratio, so it becomes slightly difficult when starting the diesel engine. And then in terms of thermal efficiency, we have said that the efficiency of petrol is about 26% and the efficiency of diesel is about 40%. And then we see that in terms of noise and vibration, say that the petrol engine, they produces less noise and vibration as compared to the diesel engine, which produces high noise and vibrations, produce high noise and vibration during the time when the vehicle is moving. And in terms of carbon content, we see that the petrol engine, they have less hydrocarbons, while the diesel engine, they have got more hydrocarbons. Thank you so much, and this is my personal experience from the summarized videos and the work performed. Thank you.